All right. So today is March 3rd. So we're going to finish off, or well, maybe finish off polymorphism. Um, I guess the other thing, so tutorial 7 is out. So some of the techniques are a little bit experimental, and while I have tested it, as things get more complex, the probability of something going wrong goes up. So just obviously let me know if you have trouble, right? So again, I've tested it on anything I can think of, but that of course is not everything. You guys can think of a lot more things to try and do to it, or more techniques in your own code that are actually like not wrong, but maybe the thing marks it wrong for whatever reason. So just let me know if you have troubles, technical issues. You won't be penalized for stuff that is like just a result of a blossoming complexity, right? So yeah, my goal is not to catch you on a technicality. My goal is to try and evaluate your work. So also test 2. So we will talk a little bit more about it by next class. I hope to have the practice test out. I'm looking at all the material that we're supposed to cover for test 2, and it's everything on assignment 2 and everything on assignment 3, and that's a lot. I don't really want to give you a huge test. So I'm probably going to scale it back and it'll be more assignment 2 with like a little bit of inheritance flavor stuff. So a lot of memory management. And of course, all the traditional stuff, right? Like adding things to a collection class and retrieving them and managing the memory around all of that. And then maybe a little bit of inheritance and stuff like linked lists, which you did on assignment 3, I'm probably going to save for the final. Okay, I just don't want it. I don't want that heavy of a test. I just want something that you guys can get done in like 60 minutes or whatever, with a little bit of coding by hand, of course, but nothing, I don't know. I don't want a big, weighty, heavy test right here. So it'll be a little bit light, and you'll get a practice quiz, so you'll see exactly what I mean. All right, questions? And for this quiz, I'm probably not doing any multiple choice. Probably your final exam will be very heavy on the multiple choice, right? Because I have 3 sections and it's just a ton for me to mark myself. So I'll save all the multiple choice for the final, which is kind of, probably good for you guys. Just a reminder though, you do have to write one of the tests, right? So test 1 or test 2. So if you miss test 1, you have to write test 2. Yeah. All right, questions? Yeah. Right. I will. I mean, if you guys have any suggestions, I mean, I definitely think about those types of things, right? I'm not going to commit to anything right now, but I do, because yes, there are scenarios that are like not fair for people who come to write the test when maybe they were underprepared. You're right, yeah. It would have been better strategically to just skip it. So yeah. So this second question here is along those same lines, and so I don't have it's very difficult to make everything completely fair across the board, but I will think about it. I will think about what's the best way to do that. The one way that I do it is I try to make, like, I think test 1 was kind of easy. I mean, everybody did really well on it, or most people did really well on it. And test 2, I kind of intend to make easy as well. It's really just to check in to make sure that, hey, you know how to write this code. Right? You know how to do a little bit of coding because you have written your assignments yourself. You haven't like overly relied on ChatGPT, and you haven't like overly relied on a friend. So you've written some code by yourself, and if so, then you should find this really easy. So that's anything else. That's what I aim for, right? So test 1 and test 2 should be easy marks. The final, I'm not going to be so kind, but there are these scenarios. So yeah. If you have suggestions, bring them to me for, sometimes students have good ideas. It definitely happens. Yes, I am going to give you a practice test, just probably by next class. Can we get ideas from ChatGPT? What do you mean by ideas? Again, it's like that's a real gray area, right? So the goal is to learn. So I don't know, are you learning? I would not really rely on ChatGPT. I've told you, I've tried to sort of steer you towards what it's good at and maybe warned you against the stuff that it's not so good at. But I don't know, man. Honestly, you guys have a better perspective on this than I do. I don't, I know what, I use Copilot, and I know sometimes I have to shut it off because it's really dumb sometimes. But other times it helps me develop really quickly because I know what I want and it kind of like can guess the pattern sometimes. But I have not learned with these tools. I learned from a textbook and banging my head off a monitor and like just struggling with these things. So I don't really have a very good insight into your perspective. Yeah, so I would just caution you against relying on it too much. Even though I've tried to tell you that, well, here's a good use case, I know the algorithm I want, but I don't know the syntax. Well, then it's very good at that. I don't know, but really, I don't know much about what it's going to be like for you guys learning from this. What was this other question? Final is going to be harder than the tests. It'll probably be about the same. I do try and make it harder though. If it's multiple choice, I think it's fair to like kind of be a little tricky sometimes. I do try to make the multiple choice harder than the programming part. Yeah. Again, though, I don't know. I'm not trying to, has everyone else gotten their quiz back? Test one, I think so, right? Everybody got their grade? All right. So that's, I don't know, that I could, whatever, that's, we'll discuss it more maybe next class, but any other questions? Okay. It's on Gradescope, not Brightspace. Yes, exactly. So I have not moved it simply because I leave it on Gradescope until like all the issues are taken care of. And then I will lock the regrade requests probably this week and upload it to Brightspace for you. All right. So last class, we were talking about polymorphism. So what is polymorphism? Well, it's what Java does by default and what C++ you have to turn on. And you can turn it on for individual functions. And basically, it's if I have an inheritance hierarchy and I have a animal speak function, but of course, who knows what sound an animal makes? So in my derived classes, in my child classes, I can get more specific, right? Like a cat meows and a dog barks and a cow goes moo. And that's basically polymorphism. So I have, a vector of animals and I call speak on all of those animals and they all speak in a different way. And email me, please, and we'll figure out what happened. And so that's polymorphism. And I think and we went through that. We went through abstract classes, right? So we said if this is what's called a pure virtual function. So if I say equals 0, that means it has no implementation at this class. The derived classes can override this, but for this class, there is no implementation for this function, which means that it's an abstract function, which makes the class abstract, as long as there's at least one of these. Yeah. About, some of the dangers of if I make a vector of animals instead of pointers, well, that's not really polymorphism, because when I push things onto that vector, what's actually happening is this chicken is not getting copied into the vector. Only the animal parts are getting copied into the vector, right? So just as a warning. And then That's it. So that's all of polymorphism. And then, so this next thing that we're going to look at, dynamic casting, is not polymorphism, but it is when you have an inheritance hierarchy and maybe you want to check the type of something. You can use this runtime type information. And specifically, we're going to look at dynamic casting. If the derived class doesn't make an implementation for the virtual function, it's also an abstract class. That is correct, yes. So going back to here, if this is in my animal class, or, yeah. And then my chicken inherits from animal but does not override this function, then chicken is also an abstract class, which is one of the things we saw in the example. Okay. So another thing we can do is casting, right? So that's, I have an object of a base class type or some more general type, and I want to see if it's a more specific type. So I want to see if it's actually one of the subclasses. So we can use this runtime type information. You can do things like you can get the string that represents the class name, and you can check with that, or you can do dynamic casting. So you do have to be careful with these, but these things do get used, right? Java, like rather famously, not famously, I guess, but if you use like a swing library and possibly JavaFX, although I don't remember, but the swing library, if you have a GUI and somebody presses a button, it generates this event, and then the event, you have to grab the whatever is the source of the event, and you try and cast it to a button if you're sure it's a button. So yeah, this stuff is used, and so you have to be careful with it because it makes your stuff brittle. But so back to our barnyard. So we have a class animal. It is a abstract class. And then we have a bird that is a derived class of animal. We have a chicken that is a derived class of bird. And we have a cat. Do we have a pig? Yeah, we have a pig too, yes. So, all right, so we have all these animals, and they're all instances of animals. So we have a bird, chicken, cat, pig, and we do our push them back onto our vector and have a barnyard harmony, and then a barnyard dance, and then a barnyard slaughter. And then we will do a little bit of dynamic casting. So the barnyard harmony, we are using virtual functions. We're using dynamic binding, so we're getting polymorphism here. Also polymorphism for the dance. Virtual as well. All right, so now let's say, well, I want to introduce some behavior for my cat, but I don't want to go and change the cat class for whatever reason. I just want to see, like maybe there's, well, I don't know, there's not really, can't really think of a scenario, but let's say there's, for some reason, the cat, what does the cat do? How does the cat dance? The cat pounces. So then I'll say the cat, if there's a cat, it's going to run up a tree because it got spooked by the rest of the animals, right? So what I want to know is, like, is this barnyard animal here a cat? And so what I'm going to do is I'm going to try a dynamic cast. Oops. So I'm going to take a cat pointer, and then this is a template, so I need to give it a type. The type that I'm trying to cast a cat pointer. And then I'm going to pass it the pointer to the current barnyard animal. Okay, and so there's a static cast as well. We'll take a look at what that does in a minute, but dynamic cast means that I am not sure what this thing is, right? So I know that, or I suspect there might be a cat in here somewhere. So I'm going to check, but this might fail, right? So dynamic cast handles that case where this fails. And if it fails, it's going to return a null pointer. So I'm going to say if cat equals null pointer. Well, actually, I'm more interested if cat is not equal to null pointer. So if it's not equal to null pointer, that means, hey, I found a cat. So then we can say stuff like, The cat ran up the tree. Sure. Because it was scared. And just to verify that this is indeed a cat, I'm going to say, I'm going to have the cat meow or whatever. Okay, so now inside my barnyard dance, again, I'm using polymorphism here, so I'm just calling dance, but then I'm saying like, well, is that actually a cat? Cat, please run this alternate behavior. So let's see if that works. The cat says, asked it to, just to make sure that this was indeed a cat, and then the pig goes and rolls in the mud. So we've introduced some, again, this is a lot of polymorphisms and inheritance in general surround this idea that I want to write general algorithms and then introduce behavior in a way that it's sort of in the derived classes. But here I kind of cheated, right? I just needed something quick and dirty, so I used dynamic casting. So what is the problem with that? Well, this is kind of brittle for the following reason. So maybe, let's say, anyway, it's a cat that would not get spooked. This would be cat. Well, then this would be. So yeah, and then brave cat. So this cat would not normally be afraid of the animals, but, and so I can say, and then, okay, so now our barnyard dance, our barnyard hoedown, and barnyard harmony all have this secondary cat. What did I do? Okay, so the original cat, Lily, ran up the tree because it was scared, and then our brave cat also ran up the tree because it's scared. And that's not necessarily something a brave cat would do, right? So when I use like dynamic casting and this runtime type information stuff, what I do is I sort of make this brittle for implementing more polymorphism, right? I wanted a different cat that behaved differently from this cat, but now since my brave cat is a cat, this casting succeeds, and I get this cowardly behavior from a cat that shouldn't be cowardly, right? So you do have to be careful of these things, not to say that they don't have their place. The other thing we're going to do is this static cast. Now, static cast out, what I'm saying is I know what this thing is. I know that this is a cat, so just cast it to a cat, right? Don't worry about doing any safety checks. And that happens sometimes, especially when you use like little anonymous functions and stuff. But basically here, everything succeeds. So I always cast it to a cat, and it's succeeding because I guess they're not, they do have these functions. But they all pounce like a cat. I don't know. Tweet, tweet. The pig rolls in the mud. So they're still, yeah. So I managed to get this cat pointer pointing to pigs and whatnot. So yeah, static cast is only if I know that this is going to be a cat, right? In this case, I should use dynamic cast because I'm not sure. And dynamic cast will fail. We'll just return a null pointer. All right, questions? All right, so that's time type information, quick and dirty, but sometimes it gets the job done. Um, all right, so we're going to do sort of a bigger example, but first let's do some woo clap. Let's see if you guys remember all of the details of polymorphism. All right, so let's just start easy. Bonuses for doing all the woo claps. There's going to be some, because I know some people have signed in anonymously, and I'm sure they didn't do it on purpose. So there's going to be some like minimum cutoff, right? So as long as you do most of them, you can get some bonus marks. But yes, there will be bonus marks associated with the woo claps. It's just nice to get. I know like sitting there passively learning is not always the best. Sometimes it's good to get your brain engaged a little bit. So yeah, this one's sort of an easy one. So what's the output? Fox.print. Well, what do we have to consider? We're not using any virtual functions, but so what is the default behavior in C++? Let's see. I am a fox, yeah. I am a fox seems to be winning. That is correct. So by default, well, of course, it's going to say I am a fox. It's a fox type. All right, maybe something a little bit different here. So now animal, I have an animal pointer that's pointing to a fox now. So now what is the output? Oh yeah, again, there's no virtual functions. So what is the default behavior for C++? I am an animal, I am a fox. And yeah, so the answer is I am an animal because, right? So that means we're using static binding here, and this is an animal pointer, so I get the animal print function, and it prints I am an animal. Okay. What's that? Oh, nope. No, that's a typo. Sorry. Yes, assume that the fox is inheriting from animal. Yeah, good. All right. At least I'll be able to fix that for next class. That's great. Um, let's see if I did the same thing again. Yeah, so assume the fox inherits from the animal. And now we have a virtual function. I think we all, hopefully you guys know, we've sort of done step by step the different cases. And now this is the case where I have a virtual function in my base class. And yeah, so I am a fox. Indeed, we have polymorphism. It is turned on by this virtual keyword in the base class, and that is inherited. This should be, we should be inheriting from animal here. assuming or pretending that we are, then this would be when I call print on my animal, it's going to look at the underlying type and call that appropriate one. All right. So finally, what did I do here? Oh, yeah, virtual. I mean, also I'm missing the return type, eh? So yeah, I'm really batting 1,000 on these ones. Again, assuming that the fox inherits from the animal. This is now an abstract function. And, well, I don't think any of these are very, very tricky, but just as a reminder, the difference between a static binding and dynamic binding. So in this case, if I had written everything correctly, number 2 would be the correct answer. All right. I think that's all I had. Yeah. Okay. I'll leave that up in case anybody wants to register. They didn't quite get their answers in or whatever. But yeah, let's move on to, so we're going to do something sort of a bigger example, sort of something along the lines of what you're being asked to do for assignment 3. You're asked to sort of do a refactoring job for your the stuff that you wrote in assignment 1 and assignment 2. You're going to refactor it and extract a superclass or a couple of superclasses. So we're going to do something similar here. So there's a game. And it looks something like this. It's not quite it. So I think there's also, well, let me draw it and then come back to this. So there's what is it, a battle class, I believe. It's a very model view controller type of arrangement. And it has one board class. The board class is where we draw everything. Nothing fancy. I was going to rewrite this in X11 and then I completely forgot. But so we're still using little avatars and stuff. This battle class contains a hero and an orc. Not that the orc is not heroic. They are one of my favorite races. But and then these guys each have I think it's called a weapon. And so yeah, it's kind of model view controller, right? So this is the controller. This is the view, and down here, all of this is the model. So we contain all this information, and then we draw it onto the board, and the battle class just keeps track of the interactions between the two. Okay, and now, so what we want to do is, well, let's look back and see it in a little more detail. Where to go? Polymorphism. So yeah, the hero and the orc look something like this, right? So they each have position, health, and an avatar. So they have some string or character that represents their likeness. And then they have a bunch of functions. And the one thing that we are noticing here is that the member variables, they have a lot of member variables in common, right? Because they behave very similarly. They have a lot of member functions in common as well. So this is sort of like a sign that maybe this is ready for refactoring, right? And there's nothing wrong with this design. This is like, I just got this running, right? I wanted to make a game. I made a game. It's running. The design's not perfect, but like I had to very carefully go through to make sure it worked at each step. So this is not a bad idea, but now I want to refactor it so that, no, this is not inheritance here. So the question was, do they both inherit battle? This is composition, right? So the difference is, well, when we have the multiplicity indicators, that means composition. And if this was inheritance, there would be this empty triangle that sort of points to the superclass. So yeah, so we made the game. The game works. Now we want to redesign it because I want to be able to add more characters to it. Right now, I'm stuck with these two. right? And it's sort of static, and there's a lot of hard-coded stuff that I kind of want to make more abstract so that I can make changes. Okay, so in particular is take these two classes and extract a superclass that I'm going to call character. And I'm going to take all of the things they have in common out, and then I'm going to have them both inherit from character. And well, it's sort of small, but these are in italics. So those are going to be virtual, pure virtual functions, right? So character is going to be an abstract class. I don't really want to make a instance of character. I want to make specific types of characters. And so how they update and how they print will be left up to the individual characters. The rest, though, I can do in the base class. And then what happens is that, well, you can see my multiplicity indicator here goes from 2 to whatever. So I can add more characters and see how easy that is once we have refactored. So this is a battle between an orc and a hero. You're not going to be blown away. It's not the greatest. The hero is fast with good range, but does less damage. So by fast, I mean he teleports around the board. The orc is slow with short range, but does more damage. So the orc just sort of moves from one place to another. And then there's also some special behavior here. Our goal is to be able to easily add new character classes. So right now, if I add a new character class, I got to make changes in like a dozen places. But I want to refactor it so that I can just make changes in one place and then add it in. So let's take a look at it first, and then so yeah, it was made somewhere else. Okay, so the board is simply an array of characters, and this is my hero right here. The hero has a sword, and the hero swings the sword randomly left or right. The O is the orc, and they have these little, you can see the little daggers here. And they're short, but if they hit, they do a lot of damage. But also, if they happen to collide, which they did here, the hero takes a bunch of damage, right? So you can see they did like 17 damage. So colliding is particularly bad, but otherwise the hero jumps around and randomly stabs out. So he got him here, and then he got him here again, and then, oh, they both hit each other at the same time, and the hero was dead. Okay. So yeah, and if you run it again, we can get, oh, again, they collide in the end. The hero really took a beating that time. All right, so nothing, incidentally, I have, where is it? I did try some other versions, so this one, I think, Battle V2 Curses. I was like, this is sort of boring. I could try and do it with curses. What's it called? V2. Yeah, that's fine. All right, so then instead of it's one-dimensional, right? The other game, and now it's two-dimensional. The problem is they just walk around forever and almost never hit each other. And yeah, I was thinking about doing something with X11 on there, making actual graphics, and then I completely slipped my mind. But so yeah, it seemed like a fun idea, but it doesn't. I would have to like adjust the AI to actually do something useful. And then, but doing this actually made it a lot more complicated. So I didn't want it to be that complicated. So we're sticking with the simple one, which is 7. Yeah, which is this guy. Okay. So let's take a look at some of the code, and then we're going to see what kind of changes. So the battle class is, again, the controller, really simple, right? Everything is done in the update function. So yeah, this is where all the action happens. I have an instance of a board and a hero and an orc. And the board is where things are drawn. There's nothing super interesting, right? It's just an array of positions, and here's a little Boolean array to say like, well, should I draw this red or regular color? And so, yeah, I can set a particular position to be a particular avatar, a particular character. I can set it to be drawn in red if I want, and then I can print it out. Okay, and then the hero and the orc, well, they have this weapon, which is nothing but really kind of a struct, right? It just, I didn't want to make this a class. I'm trying to get something up and working. So I really just wanted to know, where do I draw the leftmost part of the weapon? Where do I draw the rightmost part? Right? No, actually, this is not for drawing. This is for determining if I hit somebody, what's the damage, and then, how do I draw it? And yeah, the update, the orc again just randomly walks left or right, and then it updates their weapon accordingly. And the hero, a little bit faster. By faster, I mean, oops, what is this? Oh, this is which way was the swinging, and this is randomly teleporting somewhere. Okay, so great. Questions? All right, so we want to extract a superclass of our hero and our orc, and we're going to do it by refactoring, which means that when I make these changes, I want this to work exactly the same after, right? So I'm going to adjust, similarly to what you're doing in assignment 3, although you are changing some functions as you go. But I want to refactor it. I want to change the structure. I want a character superclass behave exactly the same. Okay. Oh, I didn't actually look at, sorry. The last thing is this update. So this is where everything happens. So first the board resets. I update the hero and the orc, where they are and which way they're swinging. I draw their weapons first, and then I draw their characters, simply so that the characters are drawn over top of the weapons. I see who hits who, right? So the hero or the orc swings at the hero, and the hero swings back. I see if they've collided, and if so, then the hero is going to take some extra collision damage. And then I print out the board, and then I keep doing that in my main function. So I have some unit tests you can ignore. I make a battle class, and I just keep looping until the battle's over, and then I print the result. Okay, so that's essentially, so we're going to extract a superclass, and then we are going to actually, I don't know how much time we'll spend on it. I might cheat a little bit. We're going to adapt this algorithm to be more general, because here I am specifically mentioning hero and orc. I want to get away from that. I want to just have a vector or an array of characters that updates and tries to hit each other every round. All right, so character.h, I'm going to, so if I look at hero and orc, and well, this is not the greatest, but I don't have quite the width. You can see that they have all of the stuff in common, right? Everything except for this collide function, and all of these in common as well. So I want to extract all the common stuff up into my superclass. So here's my hero, get position, and if I look, actually, yeah, so these are just getters, so they're the same between both classes. This getHit function, although I didn't show you, if I look at the orc.getHit function, it's exactly the same. So all of these I can extract to my superclass. So I'm going to take these, and I'm going to get rid of them. Actually, no. I'm going to copy all this so that I have just something better to go off of. Okay. So I put this in my character. Change the header guards. That's very important. Include weapon. That's great. Change hero to character. Oops. And now, yeah, these are all fine. This is going to be pure virtual, right? I do not want to have any concrete instances of characters. I want only concrete derived classes. And this collide, this belongs to the hero. I don't need that. I do want all of these, but now they're going to be protected because I want the hero to be able to access all this stuff. Okay, so this is looking good. This is my character class. I'm going to make a second one, character.cc. And okay, so the hero no longer needs this stuff. Override the update, and the collide will stay. This is gone, right? This is in my base class, which I'm going to include here and inherit from. Okay, so, and then here, okay, so there's a bunch of stuff. I should, I'm probably going to leave this. I should sort of make a character constructor, but, you know, let's not get too pedantic, I guess. We'll just get something working and then understand that we could update things later. So character.cc, I want include character.h. Okay, so that's pretty close to being what we want. So these are pure virtual, so I have to override them in my hero class. These are all implemented, and my orc is still an orc, but my hero should be a version of a character now. The last thing I need to do is this. Let's make sure that this gets compiled along with everything else. Okay. Technically, I've refactored and it should work. It almost never works on the first try. Right. Undefined reference to hero get position. So what did I do? Something unsaved. It's fine. Character. Did I mess up the make file? No objects. All right. Then if I can't find anything, I'll just do a clean step. And then make undefined reference to the, yes. So I did not make a constructor, which I don't really want one. I guess I need one. All right, so let's just make an empty one. Again, that's not really great design at that point, but all right, perfect. After all of that, I get, well, it looks like the same behavior, right? My hero's jumping around, stabbing everything, and here he manages to stick the orc, and here they hit each other, and then here there's a collision, and that ends the hero's day. Oh, this was a quick one. All right, so yeah, that's a little bit of refactoring. We're gonna finish the refactoring, but any questions? Okay, so now my orc, well, it should be sort of easier. Include character.h. I've already done all the grunt work. I don't need any of this. These are going to be virtual. I don't have to do this, but I'm being nice to any other developer that wants to read it. I don't need that because I'm inheriting from my character now. And then I'm gonna, this is all in my superclass. And then I just have my update function is my own, right? How my character moves and swings is up to me. But all the other stuff is, of course, in my base class. And now, well, the hero really stuck it to him that time, but yeah. So it seems to be working okay. The orc is lumbering around trying to stab somebody, and the hero manages to get the best of him. All right, this is a long one. Okay, so successful refactoring. I just took the common stuff out. Now there's a lot of, it's because it's C++, there's a lot of little details, a lot of little stuff that can go wrong, especially with the make file. Forgetting to put this in there, that can be, of course, a problem when you go to compile. But yeah, questions? All right, so what does that mean? Well, and not change the core algorithm. The core algorithm is not great, right? Because I'm specifically referring to hero and orc, and I really want to refer to general characters. So let's update that a little bit, and then just a little bit, and then we'll cheat and finish the rest. But what I want here, instead of a hero and an orc, I want vector of character pointers. And I'm not going to, we're going to ignore stuff like deleting the characters when we're done. But all right, so let's go here. Now we're going to see a bunch of errors. Still want to be here. Okay, so here I want to, my characters dot push back a new orc and hero. Okay, so now everything is going to be, all this stuff that used to be done like this is going to be done kind of in a loop. Some of it's a bit of a pain, but so let's say int living equals characters dot size. So the number of living people, or the number of people who are initially alive, is equal to that, and then I'll just say 4. And almost everything we do will look something like this.
What is
We're
happening
going
to
to
this
use
battle? Push back, new
for
hero.
each loop here
Temperature is over.
for us.
Character.
So for each character in my character array, I'm going to say if they are dead, then living minus minus. Right, so simple enough, and then return living is at most 1. Okay, so if there's 2 people or more living, then the battle's not over, but if we are down to 1 or 0, then the battle is over. Okay. Questions on that? All right, we'll do a few more of these things. Just to show you, okay, so we're resetting. We want to update everybody. Well, that's kind of simple, right? Whoops, that's not what I wanted to do. update everyone. Perfect. We want to draw everyone's weapons. Well, again, let's take this. Instead of hero.getWeapon, take this character. Incidentally, the way this function is set up, this set character where I have to like grab the weapon, specifically the weapon avatar, and then grab the left-hand side of the weapon, like this is just awful design, right? Like hopefully you can see that. I am exposing way too many details here, and if I ever change the way this operates, then I'll have to find every instance of this and change like all the arguments. I should be just putting in set character. I should be just throwing in like a character, a game object, right? For another day though. So yeah, these no longer needed. And same thing here. I've drawn all the weapons. I want to draw all the characters. So now it would be get avatar and get position. And then I don't need that, right? And this is good for any number to hit. All right, so now I need like a double. But, and well, also this, so I'm going to cheat a little bit. I'm going to go into some one that is finished. To steal the code. Oh yeah, here I made sure that anyway, I checked to see if they're dead before I updated them, but I believe I moved that. So here is, oh God, this is awful, eh? But it'll work. No, it won't work. All right, so I changed things a little bit. I'm going to do this by hand. But what I want to do is I want to have everybody swing at everybody. So this is C1, this is C2. And then if C1 is not equal to C2 and C1 is not dead and C2, oops, is not dead. Well, then if all of those things happen, then we can take a swipe at each other. C1 get hit. Yes. If C1 gets hit by C2, then red. Okay, that should cover it, all of this. Then we have this special behavior. Okay. Let me see if I can grab. Those won't work, but perhaps these will. Yes. Board print and print result. So print result is a little more complicated, but it's not too bad. We just, see if anybody's left alive and then print out that they are the winner. Are So I did make some changes, and now my actual working one is not working. Oh wait, so this is, if I'm lucky, this will still work. If not, we will jump into the version that I know works. All right. Oof. Oh, that's nice. Usually if you make that many changes in a row, something goes wrong, but I got lucky today. So everything is still working the same way as before. So I extracted a superclass, a base class, a general base class, and now I have used that base class in my battle implementation. So now everything is set up. I have a nice general algorithm. I have a general base class. And now I can add subclasses and have them join the battle. All right, questions? Okay. Finally, let's make a wizard. Going to steal all of this code. That should do. Swing. Um, swing.h. Why is that there? Or do I? Okay. All right, I don't need the collide. And then wizard, I believe, maybe I'll just, I can't steal it now because, well, maybe I can. Okay, so how does the wizard behave? Well, the wizard has a fireball, so their position, they're going to teleport around. The fireball, they're going to throw at random across the playing area. And then the fireball is like 5 characters wide, and it does 7 damage, and that should make things interesting. Okay, so now I have a wizard class, allegedly. We'll see if it works. Weapon, standard, yeah, everything looks good. Add the wizard to the make file. Make sure it compiles first of all. Good. That's a good sign. Let's add this wizard to the battle. And to do that, simple. New wizard, of course, the compiler is not sure what a wizard is. So I'm going to let it know. Okay, and now we should have a wizard running around throwing fireballs at stuff with any luck. And yes, so yeah, there's my wizard teleporting around and throwing fireballs and generally torching people. And then finally, the hero in the end wins. So there's a couple bugs, right? My wizard keeps moving around even though they're dead. So, you know, at the beginning of the update function, you can just check to see if they're dead and if so, return and stuff. But yeah, so that is the whole idea behind polymorphism and refactoring. And essentially your assignment 3 is that you want to change the design of the existing code so that you, well, of all, so that everything still works the same as before. But of course now assignment 1 and 2, you should have an absolute layout that works, and a flow layout, and also a button and a text area, which are basically the same thing anyway. So you should be able to have all those things combined, and then at which point it's easy to sort of add like a new thing, like maybe a label, right? You can just, well, we should have started with a label technically, but you can make a label class that is a component and then just not draw the background rectangle, but just draw the text. And then that can go wherever, right? And then you can design other components that are really just existing components combined, right? In a flow panel, maybe you can put a bunch of buttons and make like if they can press one at a time, so to something like that. Right, so that's the idea behind assignment 3 is something like this: refactoring, getting a better design, and then being able to make changes. Right, questions? Okay, so we'll come back to this one more time because there are other optimizations we can make, but for now, so we're getting into more high-level stuff. So polymorphism is more high-level, and now that we know polymorphism, well, a lot of design patterns depend on polymorphism. So what is a design pattern? Well, it's just really it's just a solution to a common problem. And what happened was there were a bunch of people who got together. You know, programming, again, is a really young field. So these 4 people got together, and they were talking about all the solutions to their common problems. And they're saying that, well, actually, they have the same solutions, right? They all hit on sort of the same patterns in order to solve these problems. And you've probably come across them well, right? So depending on what sort of programming you've done, if you've done GUI programming, then you've seen, for example, the observer pattern, right? I want to, you know, if somebody presses this button, I want to know about it. So I register, I say like, listen, I give it a listener or something, right? I forget how exactly it works, but it was something like that. So we're going to talk about major categories of design patterns, and then we'll look at a few specific examples. We're keeping it really simple. Before you'll go into a lot more depth. So yeah, we'll talk about anti-patterns, and then we'll apply a strategy design pattern to our game we just saw, right? Because it's sort of silly that, well, maybe my wizard wants to pick up a sword and stab somebody. Or, you know, I get a fireball spell from my orc. Like, so they should be able to swap out that behavior without having to make like a special subclass of orc that with fireballs. Okay, so what is a design pattern? It's a way of organizing code to address a common problem. How do we organize it? Often through inheritance or polymorphism. It's really good for this, but not always. Sometimes delegation via composition or composition of certain operations to be implemented. You guys have seen, if you've seen Java and if you've loaded files, you've seen the decorator pattern. Getting ahead of myself. We'll come back to that. So some problems recur over and over time, different programmers notice they arrived at the same solutions. This is the sort of seminal book on the subject. So these 4 people were the people I was talking about, known informally as the Gang of 4. The Gang of 4 book, and it is rather, you know, arguably, this is sort of where the idea behind design patterns was formalized. It's not that it was invented, because everybody had been using them, but here was where it was formalized. So the types of design patterns, at least in the book, are creational, structural, behavioral, and architectural. When we talk about a design pattern client class, we're talking about the class that is using the design pattern, or in some sense benefiting from it, or whatever. So creational design patterns, so specifically specify how to create objects, right? So you've seen, if you use Java, you've seen a factory, I guarantee you. But factory, abstract factory, singleton, right? So where I make my constructor private, and then I just have a function, like give me the object, and then only one instance of it exists. At any rate, sometimes constructors are not the best way to make an object. Sometimes I need to read from a file, right? I have a huge configuration file. Or like maybe it depends on the platform, the operating system. So constructors, I put a whole bunch of that sort of logic in my constructor. I just want to build my object. So how I get the information, well, that I can make a factory. The factory figures out where to get the information and then build something for you. Structural, how objects relate. So objects relate through inheritance and composition, but facade, bridge, decorator, proxy, right? As mentioned, decorator, if you've used Java files, you have a file buffer wrapped in a print writer in a, what, I don't know. But that's the decorator pattern, right? So you have each one of those things you adds functionality. Behavioral design patterns, how objects communicate, right? So observer, that's where we talked about, I have a button, I want to know if somebody presses that button, so I register as an observer to that button. Strategy, which we're going to implement, and visitor, which I don't know why, but I kind of like it. It's very hard to explain. There's also architectural design patterns. These are, depending on who you talk to, some people get really pedantic about this stuff, right? So to say that architectural styles are not design patterns, I really don't have a strong opinion. But like client server, model view controller, peer-to-peer, this is sort of the overall structure of your program. All right, so we'll take a look at a couple of simple design patterns, and the simplest one of all is the facade. It's arguably not even a design pattern, or at least I would argue that. It's really just a general interface for something. So we've already seen, we've done that with our animal class, with our character class. So facade provides a simplified interface for a complex class. The client class calls simple operations on the facade class, and the facade class takes care of business behind the scenes, right? So you don't have to do all of these detailed things. So an example is Python. You can think of it as a facade language. So Python is really making C calls behind the scenes. Of course, if you tried to make those C calls, if you tried to write all of that in C code, you probably know what kind of nightmare that would be. Python makes it nice and easy. So this is the uses association. So this is sort of a, a UML light here. So we have a client class that makes calls on the facade class, and the facade class goes down and does a bunch of complicated stuff, perhaps by calling complicated classes. And another good example of that is files, how easy it is to open a file, right? I mean, I can remember, well, I don't know. It was a while. Open a file in C and you're actually looking at the bytes and things like that. Well, that used to be sort of all file interactions, right? You'd have to be very careful not to run off the end of the file. But now in C++, you just say, well, here's a file name, open it. And then you say, well, did you open it? No? Okay, well, we'll crash, I guess. But if you did open it, then I can read and write. And all of that is sort of handled. It's so easy now compared to what is actually happening behind the scenes, which is a lot of stuff. Operating system calls, device driver calls. Observer is a behavioral design pattern. Observer classes are informed of changes in the subject class, right? So the subject class can maintain a collection of observers, right? I have a button that somebody presses, maybe a bunch of people might be interested in it. And then we have the observer class that subscribes to notifications and updates itself, usually with a callback function. This is also known as the publisher subscriber, and this is often used with model view controller. So the UML for it would look something like this. This is the general version. So I have a subject that my observer is going to subscribe to changes in the subject. So I'm going to call subscribe, and maybe I'm going to pass in an instance of myself. And that instance of myself will have this update function. So now when something happens in the subject, it runs through all of my observer objects and calls update on them. And then, well, in my concrete observers, of course, these update functions, well, presumably they get stayed here. This part of the UML diagram is not necessarily, we don't necessarily need this to be an observer, but this is one example of it. And sort of a more concrete version of that same UML. Let's say I had an Xbox game, right? Like multiplayer online. Then I have a bunch of views. So I'm subscribed to be playing in this game, maybe Fortnite or whatever. And then every time something happens, they call update. So you get, I grab some more information from my game. Yeah, you get the idea. And then maybe you can have like, while you're alive, you have one view. While you're dead, or people are dead, you have another view. Things like that. Visitor UML. So this has a couple of uses. One of them is to solve the multiple dispatch problem. And the multiple dispatch problem is something like this. So I have a function, and A and B are arguments, but A and B both have subclasses, which means that, well, let's see. Do I have a better example? Yeah, so if I have a bunch of different space objects, my space objects are spacecrafts, asteroids, but I might have, this is not the greatest example either, is it? See, I looked at this earlier, and I wanted to update, but I looked at it and it's like, oh no, it looks fine. But now that I'm actually talking through it, it's not fine. So basically I have a subclass A1 and a subclass B1. And then I have a subclass A2 with B1, and then I have a subclass A1 with B2, and then I have a subclass of A2 and B2. So I have all of these functions that I need to write. And so how do I know which one of these to call if I'm using polymorphism? And the visitor design pattern is one way to resolve it. Right, for example, I have an element, and I have an element type A and an element type B, and I have a visitor type A and a visitor type B. So when I call accept on the element and pass in my visitor type, then the visitor type calls the visit, and which function is, of course, based on the specific type. And yeah, then I can, I don't know. It always kind of stalls here. It's a neat pattern. It can do some interesting things. I'm not going to spend too much time trying to suss this out, but any questions on this? All right. I have a good example that I really hold it in just out of stubbornness. I really get rid of it. It's kind of, I think it's just confusing. Factory design pattern is a creational design pattern. So sometimes, I want to make an object. As mentioned, a constructor is not the best way. So sometimes I want to get some information from disk, and I really don't want my like say student object to be an expert on how to access things from disk, right? My student object should be a student. So when I want to build a student and I need to go to disk, or I need to go across the internet or whatever, and maybe I want to put all that stuff in a factory. So now the factory can gather all those resources for you, build the correct student for you, and then give you back a student object. So yeah, this is encapsulate creation of derived objects, right? So often we are talking about having a base class, an abstract base class. None of those examples I told you use inheritance, but there are some good examples that do. I have this analogy. I got it from Stack Overflow. I thought it was pretty good. So if you think of classes as people, a factory can be like a hiring agency, right? I want somebody who I know does a particular job, but I don't need to know everything about them. I don't want to even hire them. I just want you to send me a person that'll do it, right? So the hiring agency will see if you have the right qualifications, and they will actually even take care of paying you. They make sure you have a full insurance number and everything is up to date. And then I just get somebody that can do that particular job without having to understand all of the dependencies and implementations and things like that. So that is the sort of abstract UML of a factory design pattern. Here's another good example that I really liked, right? If you're in a video game and you're in a town and I'm wandering around town, and of course I don't want, I want it to look sort of natural and organic. And so as I round a corner, maybe I don't, I run into a villager. Well, which villager? Well, I don't know. I can ask my villager factory, right? I look at where I am in town and then I decide, well, maybe you're close to the blacksmith, so maybe there's some people that are trying to buy armor or whatever. And the nice thing about implement around it, I can write my general logic around it, and then different villagers just get a different villager factory, right? Or different villages. And then if I want to add different villagers, well, that's easy too. I just make a new subclass, I add it to my villager factory. The game logic doesn't have to change at all, but I can still inject new behavior into my game. All right. And that brings us to anti-patterns. So these are bad programming practices. Of course, I mean, everybody has bad programming practices. Every place you work at has technical debt, right? Nothing has a perfect design. Well, maybe there's a few like Doom or whatever that people argue is really good, but so everybody sort of starts in this place and then you add good design, and the technical debt means that updating things takes longer, and good design means updating things does not take as long. But yeah, it's not like, there's never a perfect design. But a very common anti-pattern is the blob, where I just sort of put everything, I mean, literally all of my programs start out as blobs, right? Because I just want to get it working and make sure that it works, and then I'm going to put everything in its nice little class. The God object, which we'll talk about later, this is when you push everything into the base class. All right, so we are going to, not today, but next class, look at another example using that game. We're going to implement a strategy design pattern. So this is a behavior known as a behavior class. So it's a class that implements a behavior or algorithm. The purpose is that I have a client and I want to dynamically change which code executes, right? So in our case, does the wizard, what does their weapon do? Is it a fireball? Is it as a sword? We want to be able to change that dynamically without having to make a new wizard with sword class. So we want to add new behavior without breaking existing code. And 2 minutes. All right, let's walk you through these UMLs and then you can go. So where we would start, let's say we have a game character class and they have an attack. And so my player has an attack. And then there's this Inox. It's just a creature. Don't worry about it. But they have a bunch of subclasses and they all attack in their own way. And this is, this is sort of valid. So the archer has a bow and arrow, the fighter has a sword, the shaman has spells. And now well, maybe my player wants those same behaviors. So now my UML looks like this, right? So my design looks like this. I subclass my player. So there's an archer player, there's a shaman player, there's a fighter player. But I'm repeating a lot of code, right? So there's a lot of code between these are the bad guys, let's say. Their archer code and my archer code, well, they should really kind of be combined, right? So that's where we get these behavior classes, which we'll get to next class. I guess we'll come back to this next class. So yeah, assignment 3 is due this weekend, so make sure you get that along with tutorial 7. If you have technical issues with tutorial 7, please let me know. And we can accommodate that. All right, for today.
We still haven't received our test thing.
You guys haven't got your test marks?
Or I haven't yet.
They're on grade school. They not bright grade? You can check.
Like the test we wrote in cons, like that's on grade school.
Yeah.
Alright.
You haven't looked at it yet?
And also on grade school, I don't know, like there's always issues. Like I think tutorial 5, like it's like best 8 out of 10, so like it doesn't affect, but like it only like I just couldn't submit it like unless like I don't know if your email on Carlton like works, like you got the wrong email, but like
Wrong email? Really?
yeah, but
I should work. I have a CMail and a CUNet and they should both work. So just shoot me an email if you have trouble, eh? Because it doesn't tell you what's going wrong, but it tells me. So-
it only let me submit through yeah, like
yeah. For tutorial 5, that was the case, right?
oh,
Or one of the tutorials, or tutorial 6. Yes.
all right,
Yeah, that was on purpose.
all right.
So I was having a little problem with the static version from one type to its parent or subtypes, which I think you also made that problem when you're testing the barnyard animals, and then you statically cast that into a cat pointer, but it still prints the
Yeah.
that kind of function. And so it definitely has to store some original type information when it's doing static casting, because otherwise it doesn't make too much sense to me. But when I search online, I didn't find any more information. And I do it myself, and it has the same problem.
Is the question, why did it work? I guess?
Like if the method is virtual method, and then you pass that into a child that's changed.
So